Welcome friends, I am Shashikant and today we are going to solve the numericals on measurement and effects of heat, that is the topic from General Science of 8th standard. For that purpose we should have a problem which is already I have written on board. So here today we will see how to solve the numericals related to heat as well as what is the particular procedure or which are the particular steps should be followed while solving any type of numerical. Okay, that's why I have written a problem related to heat here. Now let us start to solve or to find out the solution. First of all, we should know what is the question, what is what are the steps to solve the problem. That is, first you read carefully that given problem, because whatever the steps we have to follow, whatever the calculation we have to do, these all calculations are mostly all calculations are depend on the given data. That's why reading of problem, this is one of the first step and that is so important. Okay, so let us read. In problem it is given that how much heat will be needed, how much heat will be needed to raise the temperature of 1.5 kg of water from 15 degree Celsius to 45 degree Celsius. See, I underline the given data in the problem. The mass of water is 1.5 kg. Initial temperature of that water is 15 degree Celsius and final temperature is 45 degree Celsius. From this given data, we have to solve and find out the amount of heat required to raise that temperature from 15 degrees Celsius to 45 degrees Celsius. For that purpose, first of all, note down the given data or write down the given data. Given data means what? It is one type of input which is we are getting from the problem for solution. Okay, so in given data, the very first factor or that input, it is mass of water. Okay, 1.5 kg. Mass of water is 1.5 kg. 1.5 kg. Okay, next to that, initial temperature. See, the water is heated from 15 degrees Celsius to 45 degrees Celsius. It means 15 degrees Celsius is initial temperature in this case. That's why second given factor, that is initial temperature. Initial temperature. Okay, initial temperature, that is 15 degrees Celsius. It is raised up to 45 degrees Celsius, means the final temperature of water is 45 degrees Celsius. Now see, in previous lecture already we have seen or we have discussed the theoretical points related to heat, especially related to measurement of heat, and that's why I think it is need not to repeat in this session or it need not to revise it, but just whoever attended the last session or whoever watched the last session, that particular student or person will be easily solve this problem, because in that session I have told you what is the basic of heat or what are the fundamental things related to this heat. Okay, that's why now again come to the problem. Mass of water, it is 1.5 kg. Initial temperature, it is 15 degrees Celsius and final temperature is 45 degrees Celsius. Now, as I told, there is an equation or there is a relation in between amount of heat, amount of heat, amount of heat added, amount of heat added to any substance or any mass, it is equal to mass of that subject or substance mass of that substance into temperature difference, into temperature difference. Are you getting? See, amount of heat added or supplied to any body or any mass or any substance, it is always equal to mass into temperature. Actually, Q is equal to M into Cp or Cv into delta T, where M is mass, Cp or Cv is specific heat at constant pressure and specific heat at constant volume, and delta T is temperature difference. But at this stage in this topic, without using that Cp or considering that Cp or Cv, we have to solve the problems according to our syllabus. Okay, and that's why I write here only mass into temperature difference. Only mass into temperature difference. Okay, so now come to this side. Here, say Q be the amount of heat needed or heat supplied to that water, equal to mass of water into temperature difference, that is delta T. Now, what is the temperature difference or how the temperature difference can be calculated? As we know, in problem, two temperatures of water are given. These two temperatures are 15 degrees Celsius, that is initial temperature, 45 degrees Celsius, that is final temperature. Okay, and when we subtract that minimum or lower temperature from higher temperature, we will get this delta T. Okay, this delta T is equal to final temperature minus initial temperature, minus initial temperature. Okay, in this case or in this problem, as final temperature is 45 degrees Celsius and initial temperature is 15 degrees Celsius, means the temperature difference is 30 degrees Celsius. Okay, the temperature is 30 degrees Celsius. Now we can find out the amount of heat, and in problem it is asked to find out the heat which is needed to raise the temperature of 1.5 kg of water from 15 to 45 degrees Celsius. One more question or one more thing is also asked in this problem. We will see after this calculation. Okay. Now see, Q is equal to Q, that is amount of heat needed, is equal to mass. Mass is 1.5 kg. Actually, this mass should be converted into gram. 1.5 kg gram, kilogram is nothing but 1.1500 gram. Okay, 1500 gram or 1500 gram. Now here, while solving or while using in equation, we use that mass in kilogram, only gram. Okay, 1500 or 1500 into that delta T is 30 degrees Celsius. Now calculate this. 15 into 3, that is 45, and 30. This is the amount of heat. But the unit of this heat is, as the mass is considered in gram, that's why we should go for CGS system or CGS unit of heat. CGS unit, as I told in last session, CGS unit of heat is calorie, okay, which is written as calorie in short. So the heat needed is 45,000 calorie. Okay, this is our answer, and this is correct answer. But in the question or in problem, they asked give the answer in calories as well as joule. Means again, as I told in last theoretical session, that the relation between calorie and joule, what is the relation? As I told, okay, calorie and joule, that relation we have to use here to convert this amount of heat into joule. So as I told in last session, 1 calorie is equal to it is 4.18 joule. 1 calorie is equal to 4.18 joule. This answer is correct, no doubt. This answer is correct, but it is in calorie. Its unit is calorie. Okay. Now we have to find out the same answer in joule. Means we have to find out the amount of heat in joule. For that, we should know this relation, as I told in last session, and that relation is 1 calorie is equal to 4.18 joule. So here Q is equal to 45,000 calorie can be converted into joule as 45,000 into 4.18 joule. 45,000 into 4.18 joule, and this will be equal to 188,100 joule. Okay, this is also the answer of this or solution of this question, of this problem, but in form of, or this unit is joule. Okay, in calorie it is 45,000 calorie, and in joule it is 188,100 joule. Okay, this is about the. So finally, thank you for watching and subscribe my channel to get the new and more videos related to the syllabus of 8th, 9th and 10th science in English medium or English language as well as in Marathi language. Okay.